In this part, we want to use the derivative to determine a function is increasing or decreasing on certain intervals. So now let's look at the first ones. For example, this is a increasing function, right? It's an increasing function. This is the x-axis and this is the y-axis. For the increasing function, you will see that how to use the derivative. So let's look at the derivative. The derivative is actually the slope of the tangent line. So let's draw the sum. Slope of the tangent line, right? This is the increasing function. This is also another increasing function. And this is the tangent line. So you will notice that for the increasing functions, the derivative is always positive for increasing function. And let's look at the decreasing function. This is the decreasing function, right? This is another decreasing function. So now let's look at the slope of the tangent line. Slope of the tangent line. So for the decreasing functions, then the slope of the tangent line, which is the derivative, is less than 0, right? So this is for the decreasing function. So these observations gives us the following result. So this is the theorem. And we suppose f(x) is differentiable on the open interval AB if the derivative of f greater than 0 for any x or x in the interval AB, then we can say that f(x) is increasing on the interval AB. If the derivative is less than 0 for all x in AB, then f(x) is decreasing on AB. How about equals 0? If f prime of x equals 0 for all x in AB. Do you remember the corollary of the mean value theorem? It says then f is a constant function on AB. Okay. So now we want to know how to determine. So if you are given a function, can you identify where the function is increasing or where the function is decreasing? So in other words, we want to discuss the monotonicity of this function. So now let's use an example to illustrate the method to determine where the function is increasing and where the function is decreasing. So we let f of x equals x cubed minus 27x minus 20. So the first step is we need to find the critical points or the critical values. Because you can see that the increasing is positive and the decreasing is negative, right, the derivative. So it's very important to know where the function, the derivative equals 0, right? So which is called the critical point. So let's look at the critical points. So we need to take the derivative. So the derivative is 3x squared minus 27. Right. So this is the derivative. Let's factorize it. This is 3 times x squared minus 9, right? So it's equal to 3 times x minus 3, x plus 3. So this derivative exists everywhere because it's a polynomial, right? You can plug in any number. So there's no point to make this derivative does not exist. But there must be some points make the derivative be 0, right? So this is the definition of the critical values. The derivative does not exist or the derivative equals 0. So since there is no point to make the derivative does not exist, so we can set the derivative equals 0. Then solve for x. So this would be 3x minus 3, x plus 3 equals 0. So you will have two solutions, x equals 3 or x equals negative 3. Okay, so since we have no restriction on the domain of this function, so these 3 and negative 3 both are critical values or critical points. So this is the first step. We need to find the critical values. So the next one, we can locate these two critical values on our number line. Number line, this is the number line, this is the domain for this function. This is the x, right? We locate it. This is the point, negative 3. This is another point, 3. Right? So let's divide our number line into 3 parts, right? And this part is negative infinity to negative 3. We only look at the open intervals. Here is negative 3 to 3. Here is 3 to positive infinity, right? We need to determine the derivative is positive or negative on each interval. So for the first interval, so we just pick an arbitrary number which is inside this interval, any number. For example, negative 4. Negative 4 is inside, then we plug in negative 4 into not the original function, but the derivative. Okay, we plug in negative 4, so f prime 4. We do the calculation, okay, it would be positive number. We don't need to know the exact number, we just need to know it's positive or negative, right? So we plug in 4, so here is 4 minus 3 equals 1, so 4 plus 3 equals 7, so both positive, so it's positive, right? So this is positive. So then we can get the conclusion that on the whole intervals, the derivative is always positive. Why? Because if you have another point which is less than 0, so that means you must have some point to make the derivative equal 0, right? But we know this is the only 2 points, 3 and negative 3. Would be the only 2 points to make the derivative to be 0. So impossible you get another point in this interval to have the derivative 0. Otherwise, it would be a contradiction, right? So that means if you plug in a number, so here, this would be negative 4. If you plug in negative 4, sorry, so this is make a mistake. I made a mistake. And plug in -4, so here is -7. Here is -1, so negative times negative would be positive, right? So that means on the whole interval from -infinity to -3, the derivative of this f on this interval always be positive. Okay, we just need to test a number. Then we can say this function is increasing, right? I use this up arrow to denote this function is increasing. The same thing for this interval from -3 to 3. Let's pick a number 0, plug it into the derivative. So this would be plugging 0. So here is 0 minus 3 negative, 0 plus 3 positive, 3 is positive, so positive times negative times positive would be negative. So here is less than 0. So that means on this whole interval, this is less than 0. So in other words, from -3 to 3, which would be decreasing function. The same thing for here. We plug in 4, you will get positive number for the derivative. So on this interval, the derivative is positive, so it's increasing. So now let's summarize it from this table. So where the function is increasing, so the function f x is increasing on the interval from -infinity to -3, and decreasing and union on this interval and this interval, right? So, or on this interval from 3 to positive infinity. F of x is decreasing on the interval from -3 to 3. So this is the typical way we solve a function where a function is increasing, where the function is decreasing.